Okay, good morning. Welcome to
Awesome Math number 8.
Awesome Math number 8. So we're starting, yesterday we did the sieve of Aristophanes just to get ready to talk about primes.
Yep.
And today we're starting the book, but before we start, prior to starting, I wanted to do something. And I wanted to talk about why there are an infinite number of primes.
Mm-hmm.
What do you think about that?
Well, maybe it's because if you wrote out a bunch of numbers, if you wrote out all of the numbers, then if you did the sieve of Aristophanes, you would eventually go to get every number, and then there would be infinite.
Right, but why, if you were doing the sieve of Aristophanes, maybe you'll get to a point where every number is crossed out after that number. And there would only be like 1,287,640 prime numbers. Ooh, maybe somewhere they stop. You see what I mean?
Yeah.
So are there infinitely many? Or finitely many primes? That's the question.
Yeah.
And you know who answered this question?
Who?
Euclid. Believe it or not. Do you know who Euclid is?
Sort of.
What did he do? Why is Euclid famous?
I think he studied geometry.
Right, he's usually famous for geometry, but he had a side career studying primes. Pretty cool, right?
Yeah.
So he said, assume you have P1 prime 1, prime 2, all the way up to prime n, and that's it. Okay, that's it. That's all the primes. There's finitely many. It might be 10.
Yeah.
Might be 100, might be a million, might be... What's a really big number?
Non-tillion.
Non-tillion? That's a big number. Okay, that's it. But that's still finitely many.
Yeah.
Now what we're going to do is we're going to multiply them together. Prime 1 times prime 2 times prime 3 times prime 4 multiplied times prime n, and then I'm going to add 1. What?
Well...
Now, here's a really crazy number. Now, do you want to see an example of this number first?
Yeah.
Okay. So let's assume it was just 3, 5, and 7, and that was it. Those were the only primes.
So, now what?
So now we'd multiply them together.
3 times 5 is 15, times 7 is 84.
7 times 12 is 84.
Well, 7 times 15, I think it's 105.
105, there you go. Okay, so 3, 5, and 7 are our only primes. We do 105 plus 1, and we get what?
106.
106.
Well,
Okay, there's a number.
yeah, well, if before that, 3, 5, and 7 were the only primes, 105 wouldn't be prime because it's divisible by all of the other primes. Then you add 1.
Right.
And then all of them just go away since you just added 1.
Right. Very good. Hey, high five. You made a very good observation. Because 105 is divisible by 3, 5, and 7. 106 is not divisible by 3, 5, and 7.
Yeah.
Okay, but we said 3, 5, and 7 were the only primes. So what does that mean about this number?
It's a prime.
Close. Either it's a prime
Or
itself, or there's some other prime that divides into this number that's not 3, 5, and 7.
In that case, it's 2.
Ah, but 2 divides into this.
So
Okay.
that means 2 is a prime.
We could find out 2 is a prime. But
Yeah.
this number was divisible by some other number, some other prime number that wasn't on our list. And the same thing's going to be true here. We're going to have some number of primes, like 3, 5, and 7.
Yeah.
We're going to multiply them all together and add 1. This new number is not divisible by any of these primes, just like 106 wasn't divisible by 3,
Yeah.
5, and 7. But that means this number is either prime itself or divisible by some other prime, some new prime. And therefore...
There's more primes than we thought.
Right. No matter what finite list we make of primes, we can always create a number that creates a new prime. Either the number itself is prime or there's new primes that divide it.
Cool.
So that means no finite list of primes is ever complete. Which means what?
There's infinitely many primes.
Infinitely many primes. Isn't that cool?
Yeah.
So if you go looking for primes, how long is it going to take to find all of them?
Forever.
Forever. Forever. So you think we've found all the primes yet? Even a lot of people working together?
Nope.
Nope. But people like looking for them and they like trying to find them. It's a pretty fun thing to do, especially on a computer. Alright?
Yeah.
Alright. Good job this morning, hon. Let's go talk about primes.